Morning, everybody. How's it going?
Good morning.
Everyone hear me okay?
Yeah.
Hi, Mac, Morgan, Michael, Hunter. Good to see you guys this morning. How's it going before we get started today? You guys hanging in there all right?
So far, so good.
I'm happy to chat a little bit about it. If you guys have any questions about the program or, what things look like as we start this kind of weird quarter, going to the campus or whatever. I can't remember you folks. Some of you are going to campus, some of you aren't, correct? Or no one's going to campus at this point? Okay, well, um, it's a little tricky to go to campus. As I think I said last time, I've been going to campus about every other week at this point. My grad student Serena has been going to campus almost every day now. It's fairly straightforward to set up. You just have to talk to your advisor. They have to do a lab, what's called a ramp up for reopening, and then you can start going. It might not really benefit you very much, but I have to say, I think for mental health, if you can go every once in a while, it kind of helps make it seem like things are a little bit more normal. And there are some grad students there, and they're all being very careful. They're all, wearing masks and staying, 6 to 12 feet away from each other. And so, you might want, I'm just suggesting it for mental health. If you're getting a little cabin fever, you might want to talk to your advisor about letting you come to the lab maybe a couple times a week or something like that. Seems to be helping those of us that can do it. All right, you guys are taking statistics at the same time, is that right? You're taking stat class? And who's teaching that this quarter? Not Dan, right? We have somebody else, correct? Annie? Who is
Yeah.
Annie? Oh, great. Oh, that's nice. I'm sure she's doing a great job. She's a great teacher, and she really knows how to do this Zoom stuff. In fact, I don't know if you're aware of this, but her and Liz Davis, another faculty member of the department, have a number of Zoom tutorials on their YouTube channels. And so I don't know if you folks are teaching yet, but if you have to start teaching next quarter or spring, they're really great tutorials on how to do everything on Zoom, and they make everything very intuitive. And she's a terrific teacher. You taking any other classes right now, or is it just those two?
In a brown bag, but I don't think it's a
brown bag, right? Of course, doesn't count.
Yep.
Actually, we should have a really nice brown bag this week. We have an outside speaker, and the outside speaker thing is working really well. I mean, of all, some things are working well through Zoom, and having an outside speaker from anywhere, where we all have kind of equal access to them through Zoom, and people are used to Zoom. It's working really well now. So I'm teaching a grad seminar in the spring, and I'm not sure what the topic will be, but I'm planning on having many, many outside speakers, assuming that we're still on quarantine. I'll be having many outside speakers because it's so easy, and a lot of us are kind of doing this for each other. A lot of faculty from around the country are kind of trading off Zoom presentations in each other's seminars, and it's really kind of a nice thing to be able to have. So kind of trying to make the best of it here. So okay, any other questions about anything going on in the grad program or anything like that? I understand that I'm probably the person you're going to spend the most time with, besides maybe your advisor. So feel free to ask any questions. We could take the first few minutes of every class and do that. I'll post up right now are there any questions about the grad program or anything that's going on right now before I post up some information about the class again, just to remind you of it? Anything? Okay, if anything comes up, feel free to contact me at any time. As I said last week, I am the cognitive big cheese, so I kind of know what's going on. All right, so let me share our screen then and talk a little bit more about the course. Hopefully you can all see that. So this is just what you got last week, but I just wanted to remind you and see if there's any questions on anything. Again, the best way to contact me is through email, and pretty easy to schedule meetings right now. The grading is very straightforward. We're going to have a written midterm, which will be a 3-hour exam, which you can take on your own time. The same with the final, and they will each count the same. They aren't formally cumulative. The final is not formally cumulative. However, there certainly will be things from the first half of the course that you'll need to kind of think about during the second half of the course. I won't say there'll be factual stuff you'll have to remember verbatim, but this is, as you can see, there's a lot of theory in this course. There's a lot of kind of meta theory and philosophy, and so you'll be comparing theories and things like that in your final exam, on your final exam. So it would make sense for you to go back and take a look at the material that was presented before the midterm in order for that studying. But no kind of details or anything will be tested on that final exam. And then that final take-home essay is really a chance for you just to boost your grade up. It's completely open book. You can, you're expected to use references in your answer. Most people get 90% or higher on that. Okay, just as long as you follow the directions, you should do fine. Okay, has anyone had any concerns or problems with the iLearn page if you've gone there, or the video that we made from last class? Is everything working okay technically? Yeah. Mac, you seem confused.
I haven't had any problems.
Hunter, what's that?
I haven't had any problems.
You have I'm sorry, let me turn this up a little bit. You have a what?
I haven't had any problems.
Oh, you haven't had any problems. Okay, sorry about that. I'm standing back from my computer, but the sound's coming out of my computer. So good, thank you for that. Anyone else having any problems that tried to do anything on iLearn or the YouTube channel or anything like that? Okay. Again, a nice way to study for the course is to take notes during the lecture as I'm giving it. Then go to the readings that are relevant to the lecture, and that should be pretty straightforward. You'll be able to figure it out from the syllabus. And then if you have a chance, it would be great to go back at least through part of the lecture and fill in your notes. So the idea is you're working every week to fill in the information as much as possible that's been presented in lecture. That's basically the approach. I think that works best. All right. Great. So if there's no questions, we can continue on our discussion of some of the history of perceptual psychology. And again, the big picture here is even though we're concentrating on perceptual psychology in the 203A course, the way I think a lot of us like to teach this course is to use it as an example, use that history as an example of history of psychology, history of cognitive science, certainly, and a way to kind of present theories and how the theories are kind of evaluated relative to each other. But we'll be concentrating mostly on perceptual psychology. And as I said last class, when it comes to theories of perceptual psychology, most often they address issues in vision. However, you'll see by addressing issues in touch and hearing especially, we'll be able to take kind of a different perspective on some of these larger perceptual questions. But you'll see a lot of reference to vision as we discuss theories of perception, like what we talked about last week. And just to remind you, I think this is where we left off, Molyneux's problem, which, hold on just a second. Yeah. Uh-oh, hold on. There we go. Is that where we left off? I'm trying to remember. Yeah, I think so. Does this look familiar for your last slide from last class, for those of you that have notes? Yep, good. So, as we said, Molyneux had many problems. The one that he's most famous for is the question of what would happen if a person was born blind and regained their sight in adulthood. And that obviously addresses the issue of how much our perceptual experience plays a role in our perceptual knowledge. As I mentioned last class, that is something now we can address empirically, which is really interesting. But we'll do that later. We'll talk a little bit about that later. But for now, we're going to kind of look at a sub-question of Molyneux's problem, and that is the issue of perceptual size, perceiving size. And the thing you want to concentrate on here is on line A and line B, the fact that they both project the same retinal image, the same proximal stimulus on the retina, right? Because A is big and far away, C is small and close up. And just because of the way these things are configured, and based on the laws of projective geometry, something that is big and far away will in fact project the same image as something that's close and small if they are lined up like this. And that's exactly what's being portrayed here. We have another example of it in this image where we have two people, Dr. Evil and Mini-Me, for example, and they're going to, in fact, cast the same exact image. Let me go ahead and change the thing here. Make me big, just in case you want to shift it around. But I still will be able to certainly hear you if you have any questions, so feel free to stop me at any time. And I can take a little break and answer questions then too. Okay, so to kind of recap this, how did this work? Well, we discussed the fact that we know tacitly that the program, the homunculus, whatever you want to call it at this point, knows tacitly something about the objects in the world. So that comes into play when we know that, for example, people are more likely to be the size of Dr. Evil than they are Mini-Me. And that is something we take into account when we're looking at things and trying to judge size. But maybe more importantly for this particular example, we know something about the laws of projective geometry, Molyneux would say, or the empiricists. That comes through experience potentially. And all that's saying is what I just stated before, that something large far away is going to potentially cast an image that could be similar to something that is small and closer up. Okay, so with distance goes image size when we're talking about what's projected on the retina. And if that's the case, then we can say something like this, that when we are trying to judge the size of something, we will take into account not only the retinal size, but also the perceived distance. And so all this little fancy pants equation is saying is that perceived size is a function of the retinal image, which we're given right there. It's part of the input potentially, and the perceived distance. And I think I mentioned very quickly some, very straightforward examples of this, one that you can use in your perception classes when you folks get out and open up your psychology stores or whatever you're going to do. You can draw or have your students draw a little dot on their paper, their note paper, maybe make it on their computer screen, a little maybe inch diameter dot. Look at it for a minute so it actually creates an after image, then have them shift their gaze to right under where the dot is on their computer or on the paper for a couple of seconds, note the size, and it's going to be the same size as the one they drew, and then look over to a wall in the room they're sitting in and look at the after image as it's projected, more or less, onto that wall, and it will seem to get humongous for them. It is the same exact retinal image. That's the point of the after image procedure. But because now the brain is taking into account the distance, it perceptually seems to grow. And it's a very compelling example. I always do this in my 132 courses, and they get the idea immediately. It's a kind of very striking illusion. Okay, what we're seeing here also is our first example of kind of an inference-making procedure. And we're going to get back to this in a second. It's going to prove to be a very, very critical part of kind of the big story we're telling in this class, that many theories of perception involve kind of the mind, the brain, the mental process, making educated guesses as if it's going through an algorithm. Okay, I just wanted to point this out now, but we will be talking about it in a second. But before we do, I just wanted to mention a little bit more philosophy with the British empiricists to get a little bit more into, how the British empiricists saw kind of what was real and what was perceptual. So, like other folks we've talked about before, it is in fact the case that, the perception for the British empiricists involves going out and getting clues to what's in the world and then trying to put things together in order to perceive the world. For the empiricist, of course, that comes through experience, the ability to do that, to kind of create a world, a perceptual world, is based on experience that we have with the world, whether it's touch educating vision, which we discussed last week, or something else. But what the British empiricists wanted to do is kind of divide up what is real in the world. What properties of the world that we perceive are based on real properties in the world, and what is based on just our perceptual process. Okay, so what they're going to say is some things are inherent in the objects in the world, and some things are only experienced because we're adding it through a perceptual process. You'll see what I mean here. So Locke, for example, talks about the distinction between primary qualities and secondary qualities. Let's talk about primary qualities first. Primary qualities are the perceptual experiences we have of objects that are based on the physical properties of those objects. And here we're talking about things such as an object's shape, its size, extent, and its mass, okay, how heavy it is. All those things, for example, with an apple, are properties of an apple that we can somehow perceptually apprehend. Okay, the shape of an apple being round, the extent of it being so large, the mass being so heavy, which we can experience through touch. Those are all properties of the apple itself that we can experience perceptually. However, many properties we experience, says Locke, are not properties of the object, but properties that are part of perception and only perception. And those we would call the secondary, physical properties, primary qualities are all considered physical. Secondary qualities are ones that are only a function of the perceptual process itself. And here you're going to see that you might not agree that these are only perceptual kind of outcomes, but not related to the physical properties of the object. But the fact that he's making this distinction is going to be important. So just kind of lay back on this a little bit. Locke felt that when we perceive the color of something, when we perceive the sound of something, and maybe most intuitively, when we perceive the meaning of something, those are things that do not exist in the physical objects themselves. Those are things that only are provided by the mental process, the perceptual internal process that goes on that is interpreting the world. Okay. Now you might say, well, there's reasons we perceive certain colors, right? Why is sound any less physical than light? And then meaning maybe is the most intuitive. Maybe meaning, you say, yeah, that I agree with Locke, that there's no inherent meaning in an apple. Okay, that is something that we apply through the perceptual process. I don't know. There might be a physical property that tells me the apple is red. There might be a physical property that tells me that somebody is biting on the apple. But no, there is no physical property in and of itself that can tell us something about the meaning of an apple, as something that can be eaten, as something that can be thrown at Dorothy in the Wizard of Oz movie if you're an apple tree, right? All those things are part of the perceptual process.
Are both smell and taste are physical properties, though, right?
Say that again?
Smell and taste are physical properties, and if an apple
actually, in this,
sweet,
I think Locke would say no. I think that he would say that those are not something inherent in the objects themselves. They are only something that are experienced through perception. So it's not as if you can, at his time, you couldn't really measure anything related to the smell and taste. I think, actually, this is a great question. Look in your readings. I'm pretty sure it's in there. I don't remember exactly, but my memory of it is that he thought those were secondary properties. That his primary properties were really very limited. He thought most experience that we had were, in fact, secondary qualities. I could be wrong. It's a very good question, but I'm pretty sure that he'd consider those secondary quality. I certainly won't test you on that, but if you're interested, yeah, look at it. It's a great question. Want to follow up, Michael?
I guess I was just thinking, like, chemically, we can verify that the
Yes.
sugar exists, that the smell components exist, all that kind of thing. So.
Sure, absolutely you can. Actually, you can verify that all these things exist, that there's a certain acoustic pattern that would correlate with the sound. There's a certain type of reflectance that would correlate with the color. However, those things can be measured after the fact. They weren't, according to Locke, primary qualities. Now, again, as I said, when you go through these, you might say, nah, I think that now we can measure these things objectively. So I think these are probably primary qualities too. I completely understand that. But the fact that there's a distinction, and I think maybe the most intuitive one, and the one that I think is very clearly held through modern theories, is meaning. Okay. I do want to say a little bit about sound, because this is a pet peeve of mine, because I study sound and sight. It's always been odd to me that the notion of sound as being something that is not existent without perception. So it's the old adage, if a tree falls in the forest and nobody's there to hear it, does it make a sound? And it's like, well, let's just shift that over to sight now. If a tree falls in the forest and no one's there to see it, does it reflect light? And I think most people would say, yes, absolutely, it reflects light. And yeah, it does structure sound, but sound doesn't exist without our perception. Okay, and that's an adage that we kind of continue with. I mean, people still pose that. And I think it has to do with our kind of intuitions about sound taking an extra step to be perceived. So when you see somebody clapping their hands, I ask you what you see, and you'll say, oh, I see somebody clapping their hands. If I ask you what you hear, you say, I hear the sound of a clap. And what's that clap mean? It means that somebody's clapped their hands, right? And so same with a trumpet. I see a trumpet right there in front of me. But what I hear is the sound of the trumpet, which then allows me to infer that somebody's playing a trumpet. So the idea that we hear sounds but see objects is something, I think, that is consistent through many theories of perception today. Now, not a lot of people are going to think about this, right? So this is not something that, if you're kind of driving your theories of perception based on vision, you necessarily think of. But for someone that studies audiovisual speech or audiovisual perception or auditory perception, it is a very striking distinction. We see the objects in the world, but we hear the sounds they make. We don't hear those objects, we hear the sounds they make, suggesting that sound is a code that then informs us about the objects in the world. And that's why we have the tree falling in the forest, right? If somebody's not there to interpret the code, then the code doesn't exist, then the sound doesn't exist, it doesn't make a sound. It seems kind of like a nitpicky thing. For me, it doesn't. In my research, it's absolutely critical, and we'll talk about that later. But it's going to play a role in other aspects of these theories, as you'll see. We're going to be able to distinguish these theories as we go through, based partly on how separated the perceiver is considered to be from the world. And whenever a code is assumed, that does separate the perceiver from the world in the sense that there has to be something else computed, something else processed in order for the perceiver to experience the world. So it does sound nitpicky. It's one of my bugaboos. Did your parents use that language? Bugaboos? Okay. It gets my goat. But as it turns out, it does have some really interesting implications that go beyond the sound-sight sort of dichotomy. Okay? All right. But let's take this to kind of a philosophical interpretation and talk about, well, I guess it's pronounced Berkeley, but most of us pronounce it Berkeley. Okay, another British empiricist philosopher who actually said that he was more radical than Locke. He thought that none of these things exist, primary qualities or secondary qualities, truly exist in the world, that both exist in the mind. They don't exist outside the mind. Okay? Nothing really exists. Well, no, I want to backtrack on that. Berkeley said that that we can only know the experience of the mind, and as far as we're concerned, nothing really does exist outside the mind, as far as we're concerned. Now, Berkeley thought, so if something's not perceived, so it's one of these ideas, so if you're not perceiving something, if somebody is not perceiving something, then it doesn't exist. Okay, you probably thought about this when you were in college on one of those late night times where you were sitting on the floor and talking philosophy with your friends. And it's like, well, it could be that whenever I go to sleep at night, the world disappears, right? And that's why I have the image of the Matrix, right? That whole world doesn't exist. The whole thing's a simulation, this Matrix simulation that allows people to think there is an outside world, but there really isn't. Just their senses are being stimulated to kind of convey that there is this outside world, right? I assume, it's interesting. I've used the Matrix as an example for, I don't know, whatever it's been, 20 years. Can't remember how old the Matrix is. And I can no longer really use it as a consistent example of a portrayal of what we're calling here solipsism, right? That the world doesn't really exist. We wouldn't know if it didn't, right? I can't use it anymore for undergrads. Am I correct in assuming that if you haven't seen this movie, that hopefully most of you haven't, but if you haven't seen this movie, you understand what it's about enough to know what I'm talking about? Yeah? You guys seen this or know of it?
Yeah,
Good.
I think it's a shame.
Yeah. When it came out, a lot of us had very mixed feelings. It was kind of a silly thing, but I remember watching it in the theater, and with a buddy, and my buddy says, "Well, this is kind of a, it's kind of a cheesy movie," and I said, "That's okay. It's portraying something I'm going to reference in class for the next 20 years. It's like, this is a nice portrayal of kind of this solipsistic attitude, meaning that, you're unaware that you can't be sure there's a world out outside your experience of it. It's great. I'm going to be able to use this forever. But so it turns out I can't. But for you folks, I can. That's good. Okay, so what did Berkeley think about this? Berkeley said that, yes, that's absolutely true. We can't know whether the real world is out there unless somebody is perceiving. But for Berkeley, he didn't really kind of go the kind of hard form of there is nothing real out there, because what he thought was that, in fact, even if people aren't perceiving anything at any point, God is. So God allows the world to be real because God is always perceiving the world, even if everybody's sleeping or nobody's looking at something at one time or something like that. God is always seeing it. So Berkeley did ultimately believe that there was something real, but he was what you call a phenomenalist. He believed in the idea that we cannot know anything. We cannot know if anything's true beyond the experience of our senses. That's what phenomenalism says, that we can't know anything in the world beyond just our very kind of close experience of our senses. We have no idea whether what's in the world is true, which I am going to distinguish from solipsism, which is the hardcore example of this, is like the world does not exist beyond our experience of it. Okay. Berkeley didn't fall into that because of God's perspective on things, but you get the idea. And I think the Matrix is kind of a solipsistic philosophy because the world really didn't exist in the Matrix, right? It was all kind of created through a computer simulation, and nobody was aware of that until they took the red pill or whatever, right? So I mean, in principle, we have no way of knowing this, right? And the philosophers have dealt with this forever, and it's a fun thing to think about. It's I remember going through a phase when I was in high school or maybe even college, thinking, I can absolutely be sold on solipsism. When I go to sleep, nothing exists. The entire experience I have is dependent on my awareness of it. When I'm not aware of it, it disappears. They roll up the sidewalks at night, as we used to say, right? Now, that kind of makes it hard to be a scientist in some ways. It makes it hard for a lot of practical purposes, but it's hard to be a scientist. It's hard to be a perceptual psychologist if you make that assumption. That being said, we're going to see a much more modern 1980s, but more modern than what we're talking about now, instance of this in a couple of weeks by a philosopher named Jerry Fodor, where he thinks that for perceptual psychology to work, we need to approach the perceiver as if they are, in fact, only interacting with themselves, with, of course, brain processes that they are actually, imparting to the world. And so he's going to call this, and I think it's actually a kind of a important notion in the history of perceptual psychology and cognition and all of psychology in a lot of ways, that we have to assume that the perceiver is really interacting not with the world, but with the representations of the world, and manipulating those representations, whether through computation or some more modern sorts of processes. That because the perceiver can only deal with the representations, we have to approach it as if the perceiver is in fact solipsistic, that the perceiver has no way of knowing whether the real world is out there. And that is in fact the best way to do perceptual psychology, to start doing your perception at the point where sensations are first detected, where sensations are first processed. Because anything physical out in the world, the perceiver is not interacting with. The perceiver is only interacting with representations. So that's methodological solipsism. And so it's not making any assumptions about whether the real world exists. It's making assumptions that the best way to do perception, the best way to do cognition in psychology is to do it assuming that the perceiver is only interacting with his or her representations of the world. Okay? We'll come back to it. It's kind of an interesting idea, though. Okay, let's get more into this inference thing. And I think you're going to find this very simple. This is probably a review for many of you. But the idea in this inference process, as I mentioned before, is the notion that many of our theories in cognition and psychology, as well as perceptual psychology, do kind of assume that some sort of process that involves going through steps of educated guesses, basically, underlie our mental experience. Okay, some sort of series of steps are kind of walked through in order to apprehend the world and be the basis of our experience. Okay, classic example. Ponzo illusion, you guys remember this? Ponzo illusion from your intro psychology classes. It doesn't work great for me, that one that I drew, but I assure you that the top horizontal line is the same length as the bottom one. Is it working for you? Nah, that doesn't work that great for me. I need to make a new one. But this is a great one. This really pops out to me. The top one seems much longer to me than the bottom one. If I look at it long enough, maybe. But why? The question is, assume that this works. Yeah, that one works pretty well. Assume that this works. And the question is, how do we fall prey to the Ponzo illusion? Why does this work for us? Even though you could take out a little ruler right now and measure it on your screen, and then sit back and, especially with the train track, sit back and say, oh yeah, no, but that works. I look at it really closely, and if I try to blur my eyes, maybe they're the same, but as soon as I look at it again, yeah, top one looks bigger. How does that work? Well, let's imagine you're the homunculus inside your head, and you're the little version of yourself, and you've got some information. One thing you have is a little homunculus tape measure that they give you when you're first born a homunculus. That's one of the first things you have, right? And the first thing you do is you look at the image on the back of the eye. So you're the homunculus and you're tasked with determining the real sizes of, oh shoot, let's label these let's label these A and B if you want. If you have your slides right there, you can label the top one A and the bottom one B. I just realized I forgot to do that. So A's up here, B's down here. This we'll call A, this we'll call B, the one down there. So A and B, these two horizontal lines are projected on the back of the eye. You're sitting there back behind the eye, and you've got a little ruler or tape measure, and you measure A and you measure B. Say, oh, okay, well, they are in fact the same size. So, tasked with trying to determine the real sizes of A and B, the first thing you can do as a homunculus is to measure the sizes of A and B on the retinal image. And you determine, yeah, they're the same. They are the same. However, there's a lot more in both of those images, especially the train tracks, than just those two lines. And in fact, what's going on in the train tracks, if we concentrate on that for a second, is a lot of information that there's depth in that picture, right? You know, for example, the texture here gets more dense as the image gets higher, as you go up in the image. The texture of the gravel here is more dense back there than it is here. What else? Well, maybe the most obvious thing is what we call linear perspective. And so if two lines in an image that are seemingly being portrayed as parallel actually converge towards the top of the image, then that is telling something telling us something about depicted distance. So this other cue, this kind of train tracks parallel line cue, is called linear perspective, and hopefully you've heard this term before. I'm not too worried that you know the technical details of it, but it is the type of artistic sort of tool that's been used since the Renaissance to portray depth in a two-dimensional image, right? Seemingly parallel lines that are shown to converge most often as the image goes up in more the upper part of the image, is there to depict distance, is there to depict a third dimensionality in the two-dimensional image. That's linear perspective. And so now, as the homunculus, after you put down your tape measure, you can say, aha, linear perspective, that's telling me something about the portrayed distance of bar A and bar B. And so I'm going to make the guess that as this image is being portrayed, it's being portrayed that A is actually further away from me than B is. Okay, A is further away. A is further away than B. And so if both retinal image sizes are the same, if the two retinal sizes are the same, but I'm getting information about distance. We saw from that slide, that Molyneux's problem slide, that perceived size takes into account the retinal image and takes into account the perceived distance, the experienced distance. Now I can make a guess about the relative sizes because I think A is further than B. I can infer, I can make a conclusion based on this kind of algorithm, based on this kind of series of steps, that in fact A is greater than B, that the top bar is larger than the bottom bar, and I tell my user, little Rosenblum homunculus tells big Rosenblum, hey, A is bigger than B, and I say, A is bigger than B, and you laugh at me, say, no, that's an illusion, they're the same size, and I say, oh, we tricked my homunculus. What a fun game this was, okay? And that's how we fall prey to the illusion. Now, you know, I'm trying to give you the most intuitive example of this, but you know, I wanna you know, kind of pick out a couple of important points here. One is the idea that we're making inferences based on the information we're given. Okay, we're given information about the retinal sizes of the bars. We're given information about linear perspective. We bring that information together, which then allows us to assume, to infer that A is being portrayed as further than B. And based on that, you know, that little formula we saw a couple of slides ago, we can now say that A must be bigger than B. It's an inference process, okay? It's an algorithm in that we're kind of representing things and going through kind of a process where we're, kind of reaching a conclusion based on these representations of the world, okay? Algorithm's kind of a fancy term for what we're doing here, what this process is, but you'll see it will be more useful later on. And then a final thing is this is happening unconsciously, obviously, right? If this is how it works, or maybe it's working through something much more sophisticated than your little homunculus, whatever process is happening, it's unconscious. Okay, and in fact, it's more than just we're unaware of the process. This is kind of cool. We're unable to kind of defeat the process. Yeah, pretty much. But I could show you many other illusions that may be more compelling to you, but I think that train track one's still working for me, right? Let's imagine it works for you too consistently. And if it doesn't work now, you've certainly experienced illusions where it doesn't make a difference how much you consciously know. The process unconsciously still works to fall prey to the illusion. So it's an unconscious inference process, and it's one that we'll see later on can't easily be penetrated by our conscious experience, okay? And we'll see those terms later, penetration of unconscious processes. Turns out to be kind of an interesting kind of concept that's going to carry through a lot of modern cognition and psychology, this idea that it's unconscious and it can't be penetrated by what outside knowledge we bring to bear. Okay, so let's do kind of a summary of what we're really talking about here. We're going to step back from this Ponzo illusion and think about everything that's involved in this so we can generalize it to other sorts of examples. And so this is going to be, we're going to use these flow charts. I'm going to call this one the unconscious inference process. And it's exactly what you just saw. I'm adding the word unconscious here just so we can remember that this is all happening without our awareness, certainly. And so what I'm going to do here is I said I'm going to use a flow chart, and I'm going to start with the left-hand side of the figure and show how the process occurs through a series of arrows and boxes that are representing different steps in the process, all that sort of thing. And we're going to use these sort of flow charts to distinguish the theories from each other. Okay, especially as we do this with some of the early theories where it's very straightforward to do. Okay, so we start with E in these flow charts, and you can talk about E being energy, like light energy or sound energy, or you could even talk about it as the environment or something like that. But maybe energy is the most intuitive thing at this point. Some sort of light energy gets to the receptor surface, the eye, for example, the back of the eye, but it certainly can be the cochlea as well. It could be the skin of the hand. And at that point, as the energy is imparted to the receptor surface, some physiological process allows sensations to be extracted. And what I mean here by sensations are experience of the most low-level type. Experiencing that a light is present, experiencing that there's an edge or a line there, okay? And that's all we're talking about here. We're not talking about experiencing things in the world or anything like that. That is the beginning of the kind of unconscious inference process that is involved with the kind of mental sort of steps we're talking about. And from there, we go into an unconscious inference. We start making guesses about what's in the real world based on what we've been able to extract as sensations. But we bring to bear something else with those unconscious inferences. We bring to bear our knowledge of how to interpret things like cues. And I'm just calling that box memory, but you can elaborate on it if you want. So that's where perceptual knowledge lies. It lies in a memory that allows us to determine that linear perspective is depicting distance, that superposition is depicting distance, right? you know, anything that we want to talk about as perceptual knowledge, regardless of how we got it, whether it's, you know, through experience, whether it's something we're born with, that is added to our sensation to then make good guesses about, hopefully good guesses about what's in the world. So we then have a perceptual experience. And so going through the Ponzo illusion right now, the image, the image reflects light. That light energy is reflected to the back of the eye, the receptor surface. We then extract out low-level sensations like those edges and stuff like that. We start going through a process, and because the sensations have helped to provide us with linear perspective, our knowledge of linear perspective helps with the unconscious inference that then leads to perception. Okay? That should be straightforward for everybody. I'm trying to make it really straightforward. I'm just kind of basically describing, you know, what I mean here by inference, unconscious inference. But are there any questions at this point on what I'm trying to portray here?
Sorry, it feels a bit weird here. So I'm thinking of the difference between sensation and perception, because like if you just by John Locke's point, so like there are different qualities for the stimuli, like their primary and secondary qualities.
Yeah.
So in this chart we can see like different level of qualities here. Like since for sensation we are perceiving some primary stuff, and for perception, like we are perceiving some high level stuff.
Yeah, it's a very good question. So how how does this connect to Locke's notion of primary and secondary qualities? The first thing I will say is that the actual properties that he categorizes in those things are not really considered relevant to more modern theory. So color is considered a sensation, even though it's a secondary property. So it's not like we say primary qualities are sensations, secondary qualities are perceptions. Okay, I think that's kind of distracting a little bit from the point. Now, there might be some ways in which you could think of it like that, but I don't want you to get confused in terms of what I mean by these things. So color is a sensation, right? Even though that's a secondary property, right? Mass would be considered a perception probably, okay? Even though that's considered a primary quality for Locke. What is certainly true in both cases is meaning, right? So meaning is the big one we're going to be hanging on to. So meaning is a perceptual experience for Locke, right? It's a secondary quality, and it is a clearly a perceptual experience in this flow chart, in the unconscious inference sort of thing. So there might be some interesting ways of kind of connecting the two, but I think for our purposes, we shouldn't try to confound them too much for our understanding. So this is not really following directly from Locke at this point. You understand what I'm saying? So you could go back and look at some of the philosophy and try to find the history of connecting primary and secondary qualities of Locke and sensation and perception. There might be philosophers that do that, but I think for our purposes, we want to make that distinct. Okay?
So maybe in this, sorry.
No,
Sorry.
no, go ahead. Go ahead.
Thank
unless you have a creative way of doing it to make it consistent. It's very hard. It's very hard. I'm not sure. I mean, you know, people think about write about these things for their entire lives, and I'm sure people have considered this. But I think for our purposes, we need to make a distinction here. Right, because it's very intuitive to think that primary qualities are sensation, but primary qualities such as, you know, anything that is object relevant. Right? Anything that's object relevant is really a perceptual experience in how we're portraying it here. Sensations are completely meaningless. We're just talking about, detecting edges, detecting a light being on, detecting, some sort of tone, detecting a noise, having something touching our skin. That's what we mean by sensation in this context. And what Locke thought of as primary qualities were all object relevant and therefore really perceptual properties, things that go well beyond sensation as we currently, in our modern interpretation, interpret sensation.
Then what is the difference between primary quality and secondary quality?
Well, for Locke, it was properties of the objects that really that were part of the real world, and those were primary, and secondary qualities were ones that were only derived through perception.
Okay.
Yeah.
So secondary qualities are perception, because
yeah, but the primary qualities are also things that would be categorized as things that were perceived, not sensed in this context. Again, I don't want to confound the two. I think that's the best way to think of it.
Yeah, maybe I need to think about these things.
I would do some reading and that sort of thing. I think probably, if it's not addressed in your reading, you probably find places. So what is the link between sensation and perception and primary and secondary qualities? You probably find something really interesting on it. I think it's going to go beyond what I'm hoping you'll understand in this context. Okay?
I just want to ask and make sure, like, this unconscious inference here is like a theory that's still used today.
Yeah, absolutely.
Whereas the Locke stuff, not so much.
Yeah, I've made this very, very general and kind of amorphous in the sense that, there's a lot of things that you could do to fine tune any of these boxes and potentially make it a very modern, very viable theory of perception. And we will see it being done. We're going to see that there are some very important distinctions between aspects of the theories that can tweak these boxes differently. But this is, kind of the most bare bones theory of perception, almost one of the most bare bones theories of perception you could possibly imagine. Yeah. Okay. We're not making any assumptions about whether there's a kind of computer. We're not making any assumptions about whether there's, processes that involve grouping principles or, connection strengths or anything like that, as we will be talking. Yeah, this is pretty bare bones. Okay. Other questions on this? Other ideas? Okay. Then what I'm going to do is in a couple of slides, I'm going to start talking about some more formal theories of perception when we started actually calling them theories of perception. But before we do, there's one thing I wanted to do since we had just talked about solipsism and phenomenalism and that sort of thing. And that's to talk about the idea of realism. Now, what I mean here by realism is just the, I guess, approach that there is a real world outside, okay, and somehow we can perceptually know it. There is a real world outside, and somehow we can perceptually apprehend it. That's always, we're rejecting solipsism, for perceptual psychology purposes, for, psychology purposes, we're going to reject solipsism here. Although we're going to see parts of it kind of strand its way through different theories. But realism, I'm just defining here, is that there's a real world existing, and somehow we can perceptually apprehend the real world, at least to some degree. So what I'm going to claim here is that for perception, when you're talking about perception, and I think cognition in the same way, you can talk about two types of realism. One I'm going to call a direct realism, and the other I'm going to call an indirect realism. So, and this is going to be a nice way of setting up our discussion of the different theories. So as I'm going to go through structuralism and Gestalt psychology and computationalism and all these different fun theories of perception, you should think, are these kind of indirect realism or direct realism? Okay, so what do I mean by a direct realism? Direct realism is going to say something about us having a direct way of somehow perceiving the world, that there's something that's going to allow us to not have anything between the world and our understanding of the world. Okay, that what's going to right now seem completely far-fetched because every example we've seen has shown that there's representations and the inference process works on representations. Okay, but direct realism is saying, representations are not part of what's going on. Okay, I'm not going to say very much more about it right now, but I do want to spend a lot of time talking about indirect realism, which is everything we've talked about so far and most of what we will be discussing in this course. Indirect realism just says that we have no way of knowing the outside world. We can only know our experience of it. We can only know our representations of the world. That's just the way it has to work. And everything we've talked about so far, most of what we will be talking about in this course, regardless of how ancient or contemporary the theories are going to assume indirect realism. And what I want to do now is talk about why we assume indirect realism has to be true. Okay, so let's do that. One, so this is support for indirect realism, and we'll be talking about these things again and again through the quarter. They are kind of really nice ways of kind of couching the big questions of perception, cognition, and psychology too, I think. One is this, something called the doctrine of intractable non-specificity, and that's just a fancy way of saying a very simple idea. By the way, if these terms are a little wordy, a little, maybe a little pretentious. They are described in your reading. So if you want to know the kind of basis of such a highfalutin, a title as the doctrine of intractable non-specificity, you can read about that. But here's the idea: that there is nothing specific in the stimulus that can tell us something true about the world. There is not something specific in the stimulus that can tell us something unambiguous, maybe that's the word to go, unambiguous about the world. And the great example of this is Molyneux's size problem, right? So now we're talking about Molyneux's problem, the kind of subset of problems where what's on the retina is ambiguous and can't tell us everything we need about what's out in the world. We have to have a way of interpreting that. So just, when I say doctrine of intractable non-specificity, you can think immediately of that eye looking at those two arrows, arrow C and arrow A, and here we go. Both arrows are casting the same image on the eye, and therefore there's nothing specific about their size available on the retina. It's why we need to look for other information and then start to make guesses. Sometimes, in fact, those guesses can be wrong, right? We saw that in the Ponzo illusion. Whoops, I fell prey to the illusion. What fun, okay? And so the idea here is that there's nothing specific in this case, the proximal stimulus, to tell us what's in the world. That's all that means. And we've seen examples of this again and again. The retinal image is inverted, it's distorted, it's being projected on a curved screen, it doesn't have a third dimension, and if nothing else, it is meaningless. It's meaningless, okay? So there's nothing in the stimulus that at the very least can tell us something specific about the meaning in the world. That's the first reason why we need process, why we need there to be some representation, something between the world and our perception of the world. What else? The idea that perception and stimulation are separate, that there's an independence, of perception and stimulation. And I've been saying this again and again too, that what we're given at the level of the proximal stimulus is nowhere near what we need. What we're given at the proximal stimulus, the back of the eye, are hints, are cues, are sensations. But what we experience is something we can hopefully interact with successfully in the world. So here you can think of the two trees or something like that. You know, the tree that's on the back of the eye is the stimulation here at the back of the eye is inverted, and it's much worse than that. You know, it's really made up of little points. You probably know that's the retina is made up of little points. It is two-dimensional, but what we perceive is three-dimensional. And it allows us, our perceptual experience allows us to not bump into the tree as we're walking around the forest. Okay, so that suggests that there's an independence from our perceptual experience from the stimulation. There just isn't enough on the stimulation to allow for our perceptual experience to occur. So this is kind of related to that first one, that the light to the eye, the image on the retina is not specific to the things in the world. Saying that two things that are very different can cast the same stimulation. And the other thing we're saying here for part two of this is that what we experience is something very separate from what we're given. Okay? And the most intuitive example is what we're given on the retina is 2D stimulation. What we experience in the world is three-dimensional, allowing us therefore to interact successfully. Okay? So these are both assumptions. These are both things that we've been discussing that kind of force the requirement of some sort of process and some sort of set of representations that are processed on. Okay, what else? These are going to get a little bit more esoteric here, but I think you'll find these very interesting. So this is more support for indirect realism, that we need mental process, mental process that acts on representations for this to occur. This is going to be a fancy pants name, but wish it didn't have this name, but I'll give it this name because it's in your readings, and then I'll explain it in a hopefully intuitive way. It's called the incommensurability of natural kinds, and it's borrowed from philosophy. For our purposes, we just need to understand this, that there are objects in the world that we describe with a language that we'll say is from physics. When you measure the objects in the world, including their size and shape and mass, we're describing it with a world of physics. And we're describing it in a way that has no reference to the perceiving animal at all. So actually, rather than this saying, if you want to enhance the slide a little bit, what this really means here is it's perceiver neutral, that the description we give to the things in the world are in a language of physics. Okay, so things in the world have a mass, they have an extent, they do have reflectances, all that sort of stuff, but those are things that we can measure easily by instruments that are not based on an animal's perception necessarily. But what an animal perceives we'll call the behavioral object. And all this means, behavioral object, has nothing to do with Skinner. It means it's the object that the perceiver interacts with, the animal interacts with. Okay, so again, here animal can just be substituted by perceiver if you want. And so when we talk about the object, so imagine I do have an apple here, and I can now interact with it. My interactions define this now as an object that can support my behavior. Grabbing the apple, taking a bite out of the apple, throwing the apple if I want to knock somebody on the head, or I want to throw it into the river I'm in front of, all that sort of thing. These are all ways of describing the object with reference to my behavior, with reference to the meaning of the objects as I define it, right? There is no inherent meaning in an apple, right? There's no inherent meaning in an apple. And so what has to be done here is we have to describe these objects in kind of what we'll say is a mentalese, meaning that, what an apple means to me behaviorally is something that I can eat, as something that I can throw, right? And those must all come from some sort of experience of the apple. And so we just describe that apple in what I'll say is a mental ease. Mental, these are all kind of based on representations, that inform my experience. We're describing the apple now with a mental language rather than a physical language. And there's no obvious way how to link objects that are objective out in the world that can, we just describe as, with the language of physics as having extent, having mass, having light reflectances and stuff like that. How to rationalize how that becomes a behaviorally relevant, a perceiver referential, animal referential sort of object without there being something in a mental process that connects them. What exists in the world, okay, is physical. What I experience in the world is mental. And so there's what we say in philosophy is two natural kinds here. There's an incommensurability. There's no way of talking about how those things are naturally linked. It must be a mental process. Mac, are you raising your hand for a question? Or?
No, but I do have some questions, but I'm not raising my hand. I'm just wondering the validity of the physicalist, the language of physics. I think it's also, based on our perception, right?
Well, the language of physics is based on, I think, as I mean it here at least, the language of physics is completely observer independent. There doesn't mean, you could, if little robots could measure the physical world, there could be no humans left, no animals left, and those measurements would still be considered real measurements. You don't need an existing perceiver for those physical properties to exist. However, the properties such as, edible, throwable, cuttable, whatever, those are only relevant if a behavior is, supported. So there you would need an animal referential sort of description.
So you're talking about like physical, as in like world. Things that can be mathematically proven.
Yeah, sure, I suppose. There are, I guess, ways of also describing mental experience through mathematics. But, we're talking about, if a physicist were to come in to and visit me on my river here, I look around this room and it's a garage, but I see you're looking at a river, and I say, okay, describe the things here. The physicist would say, okay, well, here's a tree, and it's so high and it's so wide, and here's the grass, and I can judge its light reflectance if you want. Here's a rock, and I can pick it up, and it's a pure physical sort of description of the world, and that is the world that we kind of assume is true, really exists. When I then experience and say, well, that's a tree I can hide behind, and that's a rock I can pick up and throw at you if you make me angry, and I perceive the grass as green. Those are experiences that are kind of considered to be meaningful, and therefore physics, is a very different way of describing things than behaviorally relevant. Okay, does that make sense? Good. Anything else on this?
No, it's good, but yeah, I just don't buy this point. But I think it is a complete theory. Yeah,
it's
sorry. I just didn't see the difference between physicalist and mentalist. But I think, I know what you meant. Yeah.
Okay. We'll certainly have more chance to talk about this. I'm glad you're thinking about it, Mac. That's great. And thanks for the question, Hunter. The next part has to do with the assumed process of perception. And what this is called is perception is propositional. And all this is saying is, it's a kind of another way of saying that that perception involves an inference-making process because we don't have direct experience with the world. Our experiences aren't directly in contact with the world. The fact that perception can be propositional, and then propositions about the world can be wrong, must mean that we are not experiencing the world directly. In other words, maybe the most intuitive way to think about this is that since we fall prey to illusions, there has to be something fallible about the perceptual experience. And if there's something fallible about this perceptual experience, it has to be something that is part of the process, right? The process, as we say, involves guessing. And for that reason, those inferences that are made can sometimes be wrong. We get the Ponzo illusion. You guys know tons of illusions. The Mueller-Lyer illusion. What's your favorite illusion? Ooh, hey, you want to hear a little story? Okay, so many of you know that, some of you might know I studied the McGurk effect, or I've studied the McGurk effect. It's not my favorite effect anymore, but the McGurk effect is that one with audio-visual speech. Do you guys know this effect? Yeah, okay, everyone knows it. So yesterday somebody said something to me. Maybe you know also that I've been featured in this kind of very well-known example of the McGurk effect that's online. It's from a BBC show called Horizon from 2010, 2011. But if you look up McGurk effect and you look for a video, it's me, okay? I'm the one that kind of appears. Somebody sent me something from TikTok. I don't have TikTok. I don't know if you guys use TikTok. They said, hey, look, you're trending on TikTok. And it was very cute. It involved this young woman, looked like a college student, that looked like she was doing a report on the McGurk effect. She goes, here's how the McGurk effect works. And she first showed my face from the video, uttering syllables. And she said, but now watch what we do. We're going to change the face and we're going to play the same syllables and you're going to hear it differently. And rather than showing my face again, you get Rickrolled. It was great. You know what Rickrolled is when you get to see Rick Astley, playing that song. It's very funny. And anyway, so somebody sent it to me yesterday. And I was so proud to be part of a Rickroll. Anyway, that's another example of an illusion, like the Ponzo illusion, like the Mueller-Lyer illusion. The fact that perception can be fooled must mean that we don't have direct access to the world, that we don't have information about the world that doesn't need to be interpreted. Interpretation must happen, and interpretation sometimes can be wrong. That's why we get illusions. Okay, that's just what perception as propositional means. And then finally, one that's kind of really related to the incommensurability of natural kinds, and this is the idea that physics is complete at the ecological scale. I probably should have reversed these numbers because this one is really associated with number 3. It's kind of a corollary with this. And what it suggests is this, that when it comes to describing things in the physical world, like apples and rocks and trees and things like that. That's what I'm talking about, the ecological scale, just where animals interact, where perceivers interact, most likely. Most of the perceivers that we'll be talking about interact at this level of what you're seeing behind me, and this is the world that perceivers interact with. Physics isn't going to give us a way to get to understanding mental experience. That's all this is saying, that here comes my physicist again, and the physicist starts measuring things, and they say, okay, this tree is so wide and so tall, this rock is so heavy, this grass has this type of light reflectance. They say, can you do anything for me, physicist? Can you do anything for me, physicist, that would allow me to explain how my awareness comes into play here, how my awareness can emerge from these physical properties? And the answer, the physicists, they say no. If you want to talk about meaning, there's nothing inherently meaningful in the way I'm, in the measurements I'm giving you. If you want to talk about meaning, you're going to have to figure out something else. And so in a way, it kind of brings forth this incommensurability of natural kinds. So physics is just complete, that physics cannot be changed. There's no type of physics one could do that would allow for meaning to be perceived. So it really is a corollary to number 3. Hopefully you can see that. Okay. All right. Any questions on any of these before we go to our discussion of our first more formal theory? Anything? Oops. Just going to get my slides up here. Okay, then let's do this. We'll take a break in about 15 minutes. But let's stop the share here for a second. And what I'm going to be talking about, and I know this is going to be a review for many of you, but that's okay. You know, the way I think about these reviews is, if nothing else, they can inform your teaching when you have to, you know, teach perception or intro psychology or whatever. And it's just good for your brain, right? It keeps you out of trouble. So what I'm going to talk about is, I'm calling this theory one, and you know, I should probably be a little bit more precise. This is kind of the first formal theory. This is when they started talking about theories of psychology. We have been talking theory all through the class, right? So the idea of an unconscious inference is kind of a theory, but in some ways it's more of what we call a meta theory. And all I mean by this is it's kind of a way of kind of approaching theory. So a meta theoretical assumption would be one of this indirect perception, right? That's kind of what I mean by meta theory. It's kind of like something that's overarching. It's an overarching kind of assumption or group of assumptions that then kind of drive a theory to be precise about how it works. So the assumption is, the meta theoretical assumption is indirect realism, that there has to be some way of embellishing the input, of processing the input. And here comes the theories that attempt to do that, attempt to explain how that happens. You understand the idea? Cool. So basically what we're doing is, you know, we're kind of going into those boxes, the unconscious inference box and the you know, memory box, and seeing how that works according to the different theories. Everything else is going to be the same in that flowchart. So the first one's structuralism. And I want to be as respectful as possible, because again, it's going to help your teaching, I think, if you can pretend to think this is cool, at least. But I actually think this is cool. One of the kind of one guy who's, if you go through intro psychology, sometimes they're Wundt and his structuralist friends are considered the kind of fathers of or fathers and mothers of experimental psychology. So these are the folks that, not just in perception, but in all of psychology, were considered to do the first kind of rigorous experiments on mental experience. Okay, so we're talking about the late 1800s. And the little backstory, you could read this. This is, if you get a chance, absolutely read this. It's really interesting. You know, Wundt was doing his science. I think he was a physician. Maybe he was also a physicist. He had a background in physics. He was working at a time where the other sciences were having a lot of success breaking down their phenomena into constituent parts. You know, so you could break the cell down into all the little organelle things. You could break molecules down into atoms. You could break, I don't know, atoms into smaller parts, all that, electrons, all that sort of stuff. And so all of these sciences were doing a great job at, you know, kind of understanding how the constituents, how the components, what they were, you know, how to catalog those components, and then how those components work together to create the sort of phenomena that you see in biology, chemistry, and physics. And so what Wundt thought is, this is great. Let's borrow this technique of kind of a kind of structuralism to understand how the components help build the structure and what the components were, and apply it to mental life. Apply kind of a component analysis to psychological phenomena, and he was interested in this stuff, psychological phenomena that we describe as being love, as being jealousy, as being nostalgia, as being anger. I mean, he really wanted to get to, you know, the sort of things that, you know, we consider maybe too, I don't know, intangible to really explain. He really wanted to go after those things. And so, yeah, let's get this down. So he really wanted to explain experience as being reducible down to its constituent parts. Okay, so experience can be reduced to its constituent parts. It's atomisms, right? And as I said, then these are I guess I have pictures of cells and molecules and stuff here. He realized very early on, though, that when it comes to understanding these fancy pants, kind of phenomena of jealousy and love and all this stuff, that to really understand its constituents, we have to start at the very smallest components of experience. Okay, so you're going to see this is how he ends up moving towards sensation. But before we get there, let's talk about what he set up as the goals of his theory. So, like you would see in chemistry, like you would see, oh shoot, I don't want this. I don't know if you guys are seeing this, Adobe Flash Player. I hate Adobe. The goals would be this: to take any experience and be able to reduce it to its elements. Maybe we can't start with love and jealousy and all that stuff. Maybe we have to start with things that are a little bit more, I don't know, simple, a little bit more fundamental. Eventually we'll be able to do that. And boy, will psychology be great. But maybe we'll have to start with perception, okay? And then after determining the elements, determine how these things are connected, how the different components are connected, just like there are, rules that constrain how, the elements can mix together. There would be rules that would determine how the psychological elements are connected together, okay? And then to determine those laws of connection between the mental elements, right? Just like there are laws that determine how the pieces of an atom can work together. There are laws that determine how atoms can work together, how elements can work together to build molecules, okay? There are, those are things that you learn in your chemistry classes, right? So yes, let's determine how the elements are connected, and let's then look for these overarching laws, these patterns that can tell us, what can and can't be connected. But these elements are not, atoms of, elements in chemistry. These are going to be elements of mental life, of our awareness. Okay. So what are the elements of our awareness? And Wundt said, before we can fall in love, before we can experience jealousy, before we can experience nostalgia, all this stuff, we need to experience what's in the world. I couldn't fall in love with my wife until I saw her. I don't get nostalgic until I hear music from the 1970s, okay? All this sort of stuff. So our experience initially is one of perception, or the elements of those would be sensations. Okay? So that for Wundt are the atomisms. That's like the elements. That's like the molecules. That's like the parts of the cell. For experience, it's going to be sensations. And now we can do exactly what he set out to do. We can figure out how many sensations there are. We can catalog them. Basically, we can set up a periodic table of sensations, and then we can determine how these sensations might be connected, and then determine, are there overarching laws that dictate which elements might be connectable and which ones might not be connectable. Okay, so this is exactly following, his friends in the other sciences. He's trying to be very rigorous about this, and if you know the story, you know that he's going to run into problems methodologically, and that's fine. But it's kind of a very respectable way of going about this, potentially very rigorous, potentially in principle. And a lot of what he said, I think, is still maintained in modern theories, even though we're talking about the late 1800s here. So let's determine then how many elements there are. and whether we can categorize them in the way we categorize elements in the periodic table into what, noble gases? Is that a category of things you chemists might know? What else? Metals? I don't know. I'm guessing about, I can't remember what the categories of elements are. I'm sure you folks are remembering that better than me. Okay, but can we do the same thing with sensation? Okay, so he talks to his friends and his students about this, saying, isn't this exciting? And it does sound really exciting to me. And so what he's going to do is now come up with a methodology that's going to be, you know, something like the methodology of what chemists do in the laboratory, you know, what biologists do with cells and all that sort of stuff, what physicists do. And for him, he realizes he's going to have to use people and their descriptions of their experience to reduce mental life into its constituents. He is going to use essentially what we'll call the method of introspection. Okay? And here, what Wundt meant by introspection is not, you know, how the term is commonly used these days. So, you know, if somebody's an introspective person, we say they think a lot about their life, they think about their experience of their you know, kind of social circle. They think about their purpose, all that stuff. That's an introspective person. This is much more fundamental than that. This is introspecting on the sensory and perceptual experience, especially the sensory experience. So in a Wundt experiment, he would bring in a graduate student and have him or her sit down and place an apple in front of them like this and say, okay, describe your conscious state. And the grad student would look at it and goes, is this a joke? Are you trying to trick me? Duh, it's an apple, Wundt. And Wundt would say, no, yes, you're correct, it is an apple, but that's not your awareness. I want you to go deep into your conscious state and tell me the pieces of your awareness, okay? The kind of components of your awareness, okay? All right, it's okay, it's not an apple. It is something round. Okay, Wundt said, very good, round. What else? It looks a little red, and I'm colorblind. You folks know I'm colorblind. Is that yellow or green? Green. Okay, green. Sorry. Good. Red and green. Okay. I see a bump kind of towards the top of the circle. Very good. And it's making me hungry. No. In fact, what Wundt would say is when you say something about the perceptual property, say of a chair or an apple, you're making a stimulus error. A stimulus error here is just describing a perceptual experience of the object, not a sensory experience of the object. Okay? Meaning when the student says he's hungry or he is seeing an apple or seeing a chair or seeing, I don't know, wood or something like that, those are all stimulus errors. Wundt wants the bare bones sensory experience. For the chair, oh God, I'm colorblind. I see, is it green or brown? I'm sorry, everybody. You know the idea. I see a vertical line. I see horizontal lines intersecting the vertical lines. Those are all true introspective conscious states, and those aren't stimulus errors. Once I say something like, I want to throw that at you, Wundt, because I'm so annoyed with this task, I'd say, nope, that's a stimulus error. That's a perceptual property, not a sensory property. So this is hard. And imagine being a graduate student in Wundt's lab. To do this consistently, to always go for the stimulus properties, for the sensory properties and not make a stimulus error. To be a good, basically, sensory meter in this would take easily 10,000 trials. He would have his subjects, his graduate students, go through 10,000 trials of looking at objects, looking at pictures of objects, and describing their conscious state, their low-level sensory conscious state, before he'd say, you have now graduated to become an official sensory meter. You can now be used as a tool to determine what the sensory elements are of experience. 10,000 trials. By the way, most of these, I should just quickly say, most of these are visual that he worked on. Some are auditory. And so, if somebody could, imagine hearing, keys jingling or something like that. Do I have keys? No. Keys jingling, if someone were asked, okay, what do you hear? If they said keys, that would be a stimulus there. You go, no, 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 no. What do you hear? I hear kind of a tinkly sound. That's the sort of thing you're looking for. That would be an acceptable response in this sort of methodology. Okay. How many sensations did they find? You'll have to wait till after the break to find that out. Okay. So sorry. I know that everyone's anticipating. I wonder how many sensations. Let's wait. Okay, so let's take a little 10-minute break, and then we will come back and continue this discussion. Okie dokie. I think we can start. You folks hearing me okay?
Mhm.
Okay, thank you. Anyone teaching now? I don't think typically students teach their first quarter. Nobody? Anyone scheduled to teach winter or spring? Just curious. Yeah, typically folks don't teach their first year, and if they do, they maybe teach in spring, but that's good. Hopefully, by the time you folks are teaching, we'll be back to normal. It'd be nice if you didn't have to worry about all this Zoom stuff. Okay, are there any questions before we continue?
Yeah, I have a really quick question. So how do you understand the reduction in structuralism?
How do you say that again? I'm sorry.
How do you understand the word reduce or reduction in structuralism?
Did I use the word reduction?
Yeah, in a previous page. In a previous.
Is it on the previous slide? Yeah.
Yeah, on a previous.
Oh,
slide.
reduce. Yeah.
Reduce. Yeah.
Yes. Okay. I understand what you're saying now. Yep. Let's do that. Yeah. So right up here, experience can reduce to its constituent elements. All I mean here is this is by the scientist that as a scientist, we can understand mental experience by reducing it to constituents or atomisms that are somehow connected through laws or something like that. So it's not as if the perceiver is going through a reduction the way it's being described now. Instead, the perceiver gets a reduced stimulus, and then it's the science's job to understand what the kind of full experience is in a way that reduces it down into the initial elements that the perceiver gets. Does that make sense? That it's really, when I say experience can be reduced to constituents, it means that the understanding of any mental experience, no matter how complicated, can be understood by reducing that experience down into its elements.
So, so this proposition is just a kind of, it's a method. It's something about methodology. It's not a
right, but it's a method, but it's also a set of assumptions saying that experience can be understood by reducing it down to its atomisms, right? So that's an assumption. It's not just a method. It's kind of a theoretical assumption.
It's theory. So it's really kind of, it's just like physicism. I don't know if I got the word right. Like physicism, like everything could be reduced to physics or something like that.
Oh boy, I'm sorry. You know, let me turn my thing if I can get this.
Well, maybe it's my bad. I mean, it's like the battle. It's like the controversy between holism and reductionism. You know,
yes.
It's like,
yes. In fact, I think we're going to see that kind of discussion as we go from here into the Gestalt approach, where the whole is considered irreducible. Here, we're saying that any experience is reducible into elements, and that's how you have to understand it.
Okay.
Does that help?
Yeah.
So it's not just I mean, yes, your method should be designed to allow us to determine what the reduced elements are, what the reduced experience is that is based on the elements. But it's assumed that experience is based on elements, and that is a big assumption.
Okay. Yeah. Thank you.
Yeah. Okay. Other questions at this point? Okay. Then let's continue with this. And we were left with poor Wundt's graduate students sitting in the lab for 10,000 trials, trying to determine what these elements are, trying to reduce their experience down into what the elements are that can make up any experience. And the idea here, of course, is that by kind of creating a periodic table of elements, then you can describe any conscious experience ultimately, or any perceptual experience at least, by referring to these elements. Like the element of red can be used again and again, whether you're seeing an apple, whether you're seeing a fire truck, that sort of thing. Of course, we're gonna have to be more specific than red. Circle can be applied to apple. It also can be applied to orange. So just like the elements can be used over and over again in different combinations, the same thing would be true of the elements of experience here. So how many elements are there in the periodic table? Is anyone keeping count? It's 140, 150, something like that. I don't remember. Guess how many elements of sensation there were? Well, if you have the slide, you already know this. He was able to, after getting many subjects, 10,000 trials of practice, and then doing many more to actually then establishing what the elements were, he got it down not to 150 elements, but to 44,000 elements of sensation. Most of which were visual, but there were also some auditory. So he hadn't even started on smell or taste or touch. And to be quite honest, these were not elements that were going to get him to understanding love very easily, or nostalgia very easily. These were elements of sensation that were just going to allow him to get to what perceptions might be, to explain how we can perceive an apple based on its elements. Okay, so it gets unwieldy very, very, very quickly, and it's not that surprising. I should mention just very quickly, I have a little bit here about how he then wanted to categorize them. There's different classes. Oops. Oh, sorry. Let me just get this up again. There are different classes that are dependent on things like quality. So it's not just red, it's how good a red it is, or how bright a red it is. Or maybe not brightness is a good thing. Let's say it's how pure a red it would be. Okay, so the purity of the red, the intensity, how bright a red it is, how loud the sound is. I don't know. I guess extent of a line, if you're experiencing it, a line, how long that line is, that would be considered part of the intensity of one of these elements. Also duration, especially if you're talking about sound. How long does that tinkly sound go on? If you're listening to me, played the music sometimes, and they'd have to imagine trying to do a kind of an introspective sort of analysis of the sensations of music, how complicated that would get really quickly. And so, they say, well, I'm hearing a low sound here and it lasts for a very short time. And now I hear a high sound and it lasts for a very long time. And those would be kind of the durations of those experiences. If, he showed them a little movie of something moving, that could also be something that they can use duration to classify those experiences. And then clarity is kind of an interesting one. He would determine clarity kind of indirectly by kind of determining what folks said first when they were describing something. So this would be almost more like salience clarity. So if the first thing somebody says when they see an apple is red, that would be considered a very clear sensory element for that object. Okay, and so here's the thing. Obviously this is going to take forever. There's going to have to figure out some way of managing these, especially if he wants to get to the real cool stuff, the stuff that the personality social psychologists try to understand in terms of those elements or those experiences. However, there's something to be said here about the theoretical implications that people can do this at all, right? So the fact that we can do this, even if, just let's step back for a second, we haven't yet really, made any evaluation of whether our experiences are truly made up of sensations. However, the fact that people can introspect, and at least to some degree, and with some consistency, not a lot, but some consistency, access those elements. Is that some evidence that, yeah, elementalism, or the fact that the idea here is just that our experience is made up of elements, even if these are it's too difficult to catalog them. The fact that we can introspect and access those elements in a somewhat systematic way, maybe that's evidence for elementalism. Now, what I mean by that is maybe the idea of structuralism is correct, that any experience can be thought of as reducible into tiny pieces. Okay, maybe just because we can do that is enough evidence that it is an important part of perceptual experience. All right. So even if it's unwieldy, even if it's a mess, even if it's way too much to come up with a periodic table, the fact that people can do it might be evidence enough that that is how perception works. Perception is built from tiny little pieces. Okay, we'll come back to that in a second, but I wanted to put that in there before we did. What I did want to talk a little bit about is how these experiences are put together. So remember, the goals besides cataloging the sensations, which was clearly what took up the most time for these folks, was the cataloging of all the different sensations. They also did speculate a little bit on how the sensations were put together. What sensations could go together? What were the rules that allowed the sensations to go together to form perceptual experience? Okay. And so this is where he came up with this idea of the principle of creative synthesis. I guess this is how it's been translated from the German. The principle of creative synthesis, it just suggests that somehow these elements are combined to form percepts. Okay. So when you see the apple and you experience red and round and I don't know, bump on the top or whatever else we talked about, if you at that point we can kind of bring together these elements, and that's what allows us to form perceptual experience. You know, you're perceiving an apple, true, but what your introspective sensations are showing you is that there are pieces of that when brought together allows you to perceive an apple. Okay? And what allows these things to come together, what allows us to know what to group together and what not to group together in order to form percepts, right? So if you see the apple and it is certainly against a background of the laboratory and the table and everything, how do we know that that's an apple? Well, what Wundt thought was that what we bring together, the elements we bring together are done so based on our experience seeing these things presented together again and again. So it is kind of a British empiricist sort of perspective on this. That the laws of association, okay, that the laws of association are going to allow us to know which elements to connect and which ones not to connect. And those can be associations either in space, so seeing something that is round and red together, superimposed on top of each other, might now allow us to derive apple from that. Or it can be, in time as well. I'm trying to think of a good one for time. Maybe hearing, I don't know, something hearing that can exist over time. The beginning of the Beethoven's Fifth, da 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 da. So hearing those notes played close together is enough for us to recognize that melody. So we're talking about association both in space, spatial proximity, which is a lot of what we're talking about visually, at least for Wundt, and temporal proximity, when things are presented over and over again, proximate in space, like redness and roundness. We then will, the principle of creative synthesis allows us then to associate those things together to derive the perceptual experience of now what we'll call apple. When the notes dot, 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 dot are played together again and again, we'll have a temporal association over time. That just means over time. And there'll be a proximity of the notes over time that allows us to then kind of group them together and provide our ability to recognize Beethoven's Fifth, the opening of Beethoven's Fifth. Okay, just want to make sure, nothing fancy at all, just using the simplest things. Okay, and then finally, we can come up with this idea that our perceptual experience is, I'm sorry, yeah, I was gonna surprise you with this. So what are kind of the overarching laws? What allows for the association? Well, luckily he could point to somebody else who was working on these sort of problems of behavior at the time, and I think you know who I'm talking about here. Does the name Pavlov ring a bell? Thank you very much. Thank you. Good night. That was a joke. Just the name Pav. You know, you're going to use this. You're going to use it in your discussion classes. You're going to say, thank you, Rosenblum. It's the dumbest psychology joke ever. Does the name Pavlov ring a bell? There you go. Anyway, thank you. Morgan's applauding. Everyone's patronizing me. Okay, anyway. The idea is this then, that, you know, what Pavlov taught us about things being associated if they're being presented together, like the bell and the food being put into the dog's mouth and all that sort of stuff, that becomes something like a meaningful association, and that allows us to either learn something like classical conditioning learning, or perceptual learning, where, you know, in this case, we've got things that are associated either in space or time. So our perceptual experience then can be thought of as the sensory elements plus the association of those elements that we get again and again, that allows us to derive a perceptual experience that allows us to perceive the world effectively. Okay, so now what we've done is kind of done at least, I guess, a first pass on those other two things, where we remember we had to come up with what allows things to be associated, what allows these elements to be associated. Well, it's temporal and spatial proximity. It's this principle of creative synthesis. What's the overarching law here? Well, it's just the same law that Pavlov talked about. It's the laws of association, where things are seen together spatially or experienced together temporally. And there you go. That's going to be the kind of overarching basis that's going to allow us to derive new perceptual experiences from this, hopefully, finite set of sensations. Okay, that's the general idea. That is really the general idea. You know, clearly, if I were Wundt, Wundt's looking from somewhere, from psychophysics heaven, and thinking, oh, it was so much more sophisticated than that, Rosenblum. It was so much better than this, but this is how we'll remember it now. And I say, Wundt, wherever psychophysics heaven is, I know it was, and we're going to see that your very important conceptual contributions are going to come back. Just bear with me, okay? We're now going to have to talk about your enemies. So we'll do that in just a second. But before we do, let's talk about these criticisms of structuralism. And I should mention, most of these criticisms, unsurprisingly, had to do with the methodology. Okay, at least initially, most of the criticisms had to do with the methodology. And so, okay. So this is bringing people in and asking them again and again to describe their conscious state at the sensory level. And as it turns out, there was some consistency. Wundt forced them to do 10,000 plus trials. So there was consistency within people to some degree, but there was not enough consistency between people. What type of red somebody actually classifies this as, whether the first thing they say is red or the first thing they say is round, is not going to be very consistent between people. And so even with, training these people up, their visual system, their introspective process for 10,000 trials, there was still not a lot of reliability between people, even on these simple things. So you might get people to say red and round, but one person might say round first, one person might say red first, person might say, oval, and one person might say, light red or something like that. And, no matter what he did, the reliability just wasn't there. And then people criticize it and say, my gosh, this is a problem with validity too, because we don't perceive the world like this. It's too conscious. This is not something that we can do. That we don't, when we go around and interact with the world, it is not as if we have immediate insight into these elements. I mean, the fact that it took you, Wundt, 10,000 trials to get people to do this means might not be testing the way perception normally works. It's too conscious of a process in perception. If we did this all the time, if this were the basis of of you know, our experience or of behavior, we'd die. You know, we'd be bumping into things and things would be hitting us all the time. This would not be an effective way to experience. So it might not actually be testing. I mean, you can get people to do it, but it might not be testing the way we actually perceive. And part of that is it pauses the process. You know, in a way, by asking people to kind of step away from their normal perceptual process of just recognizing something as an apple or recognizing a chair as something you can sit in, you're actually, you know, asking them to not do that process and, you know, kind of introspect on something that might not be related to the process. So it kind of is a kind of related to this low validity idea, is that not only is this something we don't do, when you're asked to do this, okay, you're separated from the process you're trying to understand. And then finally, you know, a theory of perception should hopefully not just describe how people perceive, or how adults perceive for that matter, but how we all animals perceive. And there's my late dog, Oscar. It's a dog I had a number of years ago. I used to bring Oscar to campus. He used to sit in my office, and I was the most popular professor in psychology when he did. I'm all for people bringing pets to offices. I know that there's rats, and as long as they're staying away from the rats on the other side of the building, I'm all for it. Tom Tsai, I think, brings it. I don't know if you know Tom yet. He's in a social personality. He brings his dog to campus, and he's the most popular professor. I mean, it's you know. I used to bring Oscar, and he was a great doggy. He was one of the smartest doggies I've ever known, but I couldn't get him to introspect for beans. I really couldn't. You know, I'd hold up a biscuit and I'd say, Oscar, what are you experiencing? And he would just say, biscuit. Or he would, you know, he would behave towards it like it was a biscuit. I could not get him to say, oh, it's brownish and it's got a line and it's, you know. I mean, the fact, I mean, to be serious now, the fact that you have no idea not only whether animals are going through something like this, but whether kids can, whether, you know, pre-verbal children can, that causes problems for a theory. You want to be able to use a methodology that applies to more than just verbal adults, right? You want a methodology that you can potentially apply to infants, and you can potentially apply to animals. And there's just no way a method of introspection is going to allow that sort of thing. Okay. Okay, those are criticisms of the method, and you know, I think they're completely understandable. And you can imagine, I mean, I think that they have been addressed in some ways now. You don't have to, you know, you can you know, do methods that aren't verbal methods where people are, you know, punching keys or something like that, where they are asked to see differences between two images, and if they can see the difference, that means that whatever is distinct between them is salient, that sort of stuff. There are kind of more covert ways of possibly getting to some of these kind of important sensory dimensions. Okay, so you can use it on babies, you can use it on dogs, potentially all goldfish, all that sort of stuff. However, the other criticisms were not on the methodology, they were on the entire idea of structuralism to begin with. That, remember, there's this idea that experience is based, our perceptual experience is based only on specific sensory elements and the associations between them. Okay. And here's the story. And I love these stories. I don't know how true they are, but a physicist named Wertheimer had his buddy over one evening. I think he was also a physicist, Ehrenfels. I believe he's a physicist too. And that the dates don't, you know, I'm not going to test you on dates ever. And I will not test you directly on the names of people saying who was the person who criticized structuralism. I'm not, and then the you know, the space answer is Wertheimer. I'm not going to ask you that, but I will use these names, but I'll never use the dates. Anyway, they were together. So this, the date information is just to kind of put it in the context of what was going on. Wundt had made, you know, quite a stir at you know, physics conferences and biology conferences, saying, I think we have a science of experience here. And, you know, did a lot of writing. It was very influential at the time. But Wertheimer and Ehrenfels, both physicists, were worried about this. They thought, can we really distill all of our, even perceptual experience, down into sensory elements and association? Are there examples where we can find that the sensory elements may not even be very predictive of what our perceptual experience is? And they chatted about this for a while, and then Ehrenfeld said, well, let's think about this. Let's think about this. And what he did is he went to Wertheimer's piano, which was in his parlor, and he played Wertheimer's favorite song, which happened to be Twinkle, Twinkle, Little Star. Wertheimer loved the song. Okay. And he played it on the white keys. Okay. I don't need to do this for you folks. You know the difference between, here. I can't make sound with this keyboard, but you know the difference between white keys and black keys, right? Okay. I could play Twinkle, Twinkle, Little Star on the white keys. Twinkle, twinkle, little star. Okay, there you go. And Wertheimer clapped and said, oh, Ehrenfels, I love when you play that song. And Ehrenfels said, terrific, I'm going to play it again for you, Wertheimer. And Wertheimer got all excited. And he played it again, but now using the black keys. Twinkle, twinkle, little star. And Wertheimer said, that was just as nice as the other one, Ehrenfels. I love that. Thank you for playing it for me. First on the white keys and then the black keys. And Ehrenfels says, don't you understand how important that distinction was? And Wertheimer said, I just know I heard my favorite song. He said, Wertheimer, listen again. He played it on the white keys, he played it on the back keys. He said, you're perceiving the same song, aren't you? He goes, yes, I hear the second time you played it, it's a little higher, but it is my favorite song, Twinkle, Twinkle, Little Star. He said, in those two cases, you had the same perceptual experience, but it was comprised of completely different sensory elements. The first time I played it, I just played it on the white keys, and I played A, and I played C, and I played E, just like that. The second time I played it for you, I played it on the black keys, and I played it with F and C sharp and G sharp, all these different keys. So the elements were different in the two cases. The sensory elements were distinct. There was no overlapping in the two cases, and you still had the same perceptual experience. And Wertheimer said, aha, it's still my favorite song. And here's what we're talking about here, that a melody, which is considered when it comes to sound, is a great example of a perceptual experience, does not seem to be the sum of its tonal elements. And for those of you that know a little music here, all I did was I transposed the melody to be played from the white keys in one case to the black keys in the other case. It's like, you probably know that any song, any melody can be transposed. If you're a singer, you know this because you have a singing range that is better fit for some melodies, some keys of a melody and other keys of a melody. We're really talking about keys here. It's in the key of C or is it in the key of C sharp, that sort of thing. And when you do that, when you transpose so it makes it easier for you to sing, for example, you are now creating a perceptual experience, the same perceptual experience out of totally different sensory elements. Wertheimer thinks. Okay. All right, so that's the first story. The second story is even more fun. Because what Wertheimer does, he says goodbye to Ehrenfels, he goes to sleep. He can't sleep very well because he's wondering, boy, is Wundt actually wrong about this? Because it seems we have a case here where perceptual experience can be the same even though it's made out of two different groups of sensory elements. And the story is the next morning wakes up and he was scheduled to take his family on a much needed vacation and a much anticipated vacation by his wife and kids. So they get all ready, they're all excited. They're going from I guess Berlin to Nice, which is in France. And they're so excited, they're going to spend time at the beach. They're going to do, they're going to wear their fancy clothes and be seen, with the hoi polloi in Nice. They're so excited. And so Wertheimer and his family get on a train. And I guess it's a night train, so they go the next night. There's a train, just in case you forgot what trains look like, all right? And this is what goes on. Wertheimer is kind of getting ready to fall asleep. His kids and his wife are already sleeping. And he's got the shade closed on the train. Now, this is kind of like a translucent, or no, I guess we can say it's an opaque shade. But what Wertheimer was able to see is shadows that were kind of created by the lights in the train station. Okay, so he's looking at the shade. He's thinking about what Ehrenfels told him the night before and his favorite melody. He's listening to Twinkle, Twinkle, Little Star over his earbuds or whatever. And this is what he sees. He sees a shadow on the shade that looks like this. Uh-oh. Shoot. He sees... Oh, shoot. I don't know why this is not playing. Hold on. Nobody panic. Is it going to play here? Yeah. That's what he sees. There we go. Forget the phi phenomena thing there. Okay, let me play it again. Let me just make sure what it is. Okay, so he sees this shadow that looks like this on the shade. And so he perceives this as, well, I don't know how you guys are seeing it, but it's supposed to be a bar that looks like it's flopping up and down. Did you guys see that when I did it? Did it? Okay, it probably didn't look that good. I apologize, but you get the idea. I mean, this is the dumbest thing in the world. He sees this bar and he goes, that is really strange. What could be out in the train station, outside the train car, that is moving like that? And he lifted up the shade and he realized he was not seeing the bar move. He was not seeing a moving bar. What he was seeing were two bars, a vertical bar and a horizontal bar, that had lights behind them. And the lights were blinking on and off. Okay? And that's what was casting a shadow on the shade. Okay? First, the light behind the vertical bar was casting the vertical bar shadow, and then it would go off, and the light that was behind the horizontal bar would cast a horizontal shadow. And he, regardless of it being two lights and stationary bars, he was perceiving movement. So, my God, this is so strange. This is actually an experience where I'm perceiving motion, but the elements are not related to motion. Okay? They have nothing to do with motion. This seems weird because this is not like just association, I would think. I'm getting something completely different out of these elements. This, by the way, he called the phi phenomenon, and it's just the general idea, now there it is again, that two stationary images shown with the right temporal relationship can give movement. But what he was sometimes called apparent motion, by the way. Go away. Okay, here's another example of this. Oops, shoot. Just have it. Is this go? Yeah, there you go. That's maybe a little bit better. That's another example of apparent motion. You're not actually seeing motion there. You're seeing three quick slides being shown in succession, and it allows you to perceive motion even though there's nothing there. And this was profound. This was profound for Wertheimer because he thought, oh my gosh, I mean, the elements available to me are just little stationary shadows, but here comes something completely different. It's not like red and round equals apple. It's stationary object, and stationary object brings about movement. You know, everything, you know, when they were talking about movement before, when Vogt was talking about movement, experiencing something in a video, you know, moving, they would come up with elements that first involve movement. So, you know, I see a rabbit jumping across the screen, it would be, I see, you know, like little shapes moving to the side, and there you have, you know, elements that are movement elements giving rise to a perceptual experience that is movement, that is a rabbit jumping across the screen. Here what you have, though, with the phi phenomenon with apparent motion, is stationary images, just a shadow here and a shadow here, but when brought together, give something completely new. And this is not an easy thing for Wundt to explain. The story is, and I don't know how true it is, you can look it up yourself, I did read somewhere that it is true. He was so excited by this insight, he takes his family and he wakes them up and said, we gotta get off, we can't go on vacation, we're going back to the lab and we're gonna show how this works experimentally in the lab and show that Wundt can't be right. Okay. I don't know if it's true, and I feel sorry for his family if it is. Hopefully they decided to go on a trip later on. Let's make this a happy ending. But Wertheimer supposedly goes back to the lab and sets this up. Okay. And he set it up, kind of in a very fun way. He figured out a way of getting some of the material that was used for the shade in the train car, so he could cast shadows. And he put the whole thing on a table where, the subject would sit, on this side. There'd be the screen, the opaque screen here, and then he'd have bars that were behind the screen and lights that he could turn on and off in succession. And he tested this in all ways, like how quickly do the lights have to go on and off? Can it go not just up and down? Can they go side to side? And he was able to do that, a single bar, and have them go, like this, like the ball showing you there. I mean, he thought this was the greatest thing in the world. This is so cool. And you get the idea. This is, apparent motion. This is the basis of movies, TV, and all that sort of stuff. Anyway, he gets his data, he brings it to the next conference, and there's Wundt, after doing his little talk on the amazing aspects of structuralism. Wertheimer gets up to do his talk and shows that, yes, we can get perceived motion from elements that have nothing to do with motion. Okay, this is like magic. It's like mixing things together and getting something categorically different from what the elements are about. Okay, and that was not something, Wundt was readily acknowledging, yes, you get perceptual experience out of the elements, but the perceptual experiences should be related to the elements. And here Wertheimer saying, no, that's not the case. You can get perceptual experiences that have nothing to do with the elements. There's no motion in the elements. But somehow you're getting motion out of this. Okay, so he does his presentation, and Wundt stands up in the audience and says, wait, there is motion here. And Wundt said, there is no motion here. There's just lights blinking on and off. There's nothing, he took a picture of his maybe even brought his apparatus to the conference. There is nothing moving here. He says, yes, there is something moving, Wertheimer. It is the subject's eyes. He says, when I'm looking at this, my eyes are going back and forth. Just like this. And that, my eye movement can be considered part of a sensory element that is then going into your experience of perceiving motion. And Wertheimer was a little dubious of this. And in fact, what he does, maybe he even did it at the conference, I don't know. He decides to take an extra set of lights and adds it to the apparatus, and then puts two bars. So there's two lights above, kind of higher up that are situated behind a bar up here, and then two lights that are situated behind a lower bar down here. And then what he does is he sets up the on and off phasing of the lights. So the bar up top seems like it's going in one direction while the bar on the bottom is going in the other direction. So from the shadow, from the other side of the screen, the shadows seem like they're going like this. And everybody experiences the same thing. Yippee, isn't this fun? They're going opposite directions. And Wertheimer says, try to now track the one on top with your eyes. And they do that, okay? And when you do that, do you lose sight of the bottom one? No, the bottom one is moving around fine. I'm seeing it go the opposite direction. He's saying, so regardless of your eye's motion, okay, if your eyes are tracking the top one, you shouldn't experience motion on the bottom, according to Wundt, but you do. There's so many other ways you could do this. You could, set up a fixation point that's right in the middle and not move your eyes and see it go back and forth. Clearly, you can get an experience of motion without eye movement. So what Wertheimer concludes is, so two opposite objects, the first way he did it was two objects in the opposite motion, and he figured out other ways of showing that the basis for the movement perception was not what Wundt said, it was something different. And so he says, is that what's going on here is actually you're tapping into an element that's part of what the perceiver is bringing to this experience. The perceiver is bringing an ability to experience motion as an elementary percept. And so this idea that the elements are the only things, with these little associations, are the only things that are important is wrong. The perceiver does bring something to this. The perceiver kind of imparts his or her way of kind of categorizing these pieces. And in some instances, you're getting something completely new out of these elements. In fact, he says, in many cases, in many perceptual cases, you're getting something that comes, kind of merges out, that has to be something much more than the elements and their associations. And this is what gave rise to their theory. Wertheimer, Kafka, Kohler, Ehrenfels was part of this too, called the Gestalt approach. And I bet you guys have learned this stuff before, but it's fun. We're going to see there's elements of it that are going to be very important in modern theories too. Okay. So here is the idea of the Gestalt approach, and it's something that Mac mentioned before. It's kind of holism versus elementism, right? Elementivism. And the idea here is what the Gestalts are going to do is say this concentration on the elements is misguided. Instead, yeah, the elements play a role of what we perceive, but what really determines what we perceive is the way the perceiver kind of brings together the elements in a creative way, in a very kind of, I guess, I don't know, emergent way, where there's something that kind of comes out of the elements that can be completely different from the elements themselves. And so, you know, the sort of phrases that that you hear is that the whole is different from the sum of its parts. You know, Wundt might say that our perceptual experience is the sum of its parts and the associations between them. What the Gestalt psychologists like Wertheimer are going to say is the whole is something completely different from the sum of its parts. So you look at the sum of its parts. You look at this. If I ask you to look down there at the bottom right hand corner of the screen, and I ask you what you perceive, you say, oh, it looks like I don't know, a deer, an elk, something like that. I say, now look at the elements, and the elements are just like a little amorphous shapes that could be, you know, traded for other amorphous shapes. What we are experiencing is the entirety, the wholeness of that. That's the important part, right? So in other words, you know, you could say, here's an element. Here's an element of, right there, there's a little, you know, shape. All right, let's use a different shape. Let's use these shapes right here. And you could say, okay, these are elements, these must be the elements of perceiving a deer. Well, you know that I could take those elements out right there and put other elements in, and you would end up perceiving a deer just as well. And these elements here could be chopped up. So yeah, they might need to be in specific places or near specific places, but the elements here aren't what's important. It's the entirety. It's the wholeness that really is important, and that, they're saying, is imparted by the perceiver. Okay, that is something that's added by the perceiver. That there's something in the perceiver that allows him or her to see the entirety of the things that go beyond the elements, right? So perception is more than meets the eye. Perception is much more than meets the eye. And oh, I guess this is just a movie down here. You don't need to, yeah, you get the idea. Another little movie there. And so when it comes to perceiving, the elements are really interchangeable in a lot of ways. The elements are really kind of secondary. They're superfluous. Yeah, you can ask people to concentrate on the elements, but the elements, you know, they're things that are not going to necessarily give rise to a specific percept. The percept can happen with the elements being interchanged, as I said. So it's the objects, it's the objects that are primary and immediate, and the way that the objects emerge is through organizational principles that the perceiver is going to apply to the input. Okay. And so therefore, again, think about the elements can be substituted for each other. You don't need specific elements really at all. there maybe needs to be a relationship between them. But again, think about the cat here. I could have so many other blobs in here with different shapes. I could take all these out and put different shapes in here, and you would still perceive the cat silhouette, okay? And so what they're saying here is the primary data for perception are not elements, but they're structured forms. They're forms that are going to be put together through specific, I guess we'll say, elegant processes that are part of the perceiver. The perceiver is bringing something very critical to the stimulus, okay, and not just associations, and not just an ability to extract the sensory data, but actually the perceiver is essentially going to organize whatever elements are given to try to achieve structured forms. And this ability to kind of organize these little pieces to give rise to these structured forms are something that happens spontaneously. It's not something that first involves picking out these elements. It's like, here, whatever elements you give me, I'm going to try to group them together and get a structured form out of it. I don't care about what elements they are very much. I want to try to apply these things I have to add to perception, these sophisticated processes I have that add to perception that give rise to my experience, okay? So, very clearly here in these examples, experience is not elemental. And if we are going to go for structuralism, we're going to miss the most important aspects of perception, which is the way the perceiver applies his or her ability to find organization. Experience isn't elementalism. It loses its critical properties. Structuralism, if we go down the route that Wundt laid out for us, then we're going to lose critical properties of what perception is really about. Perception is really about organization that comes from the perceiver. Okay? Sometimes students have a little, undergraduates have a little, I think you'd get it without a problem, but, it's like, like a structuralist house is like you're given bricks and you build a brick house. Gestalt houses, you're given bricks and the Taj Mahal comes out of it. In some ways, you don't even need bricks. You can make a Taj Mahal out of Legos. You can make it out of sugar cubes, all that sort of stuff. At the end, you've got the Taj Mahal. It's not the elements that are important. It's the entirety. It's the whole. It's the organization. Where does that organization come from? The perceiver. Okay. All right. Cool. So, let's do this. Structuralism, in terms of its flow, I could have done this. I guess maybe okay. I'm going to do a little flow chart for the Gestalt approach, and I guess I could have done one for structuralism too, where that little piece in there, well, we'll talk about what a structuralism process might look like, but let's do it for Gestalt first. So it's the same type of flow chart we saw before for unconscious inference. And the idea here is that the energy is imparted to the receptor surface. It's the back of the eye, of course, if we're talking about vision. Sensation is extracted out. And now you have kind of these, kind of representational variables to work with. But now what happens is that organizational principles are added to the sensations. Okay, organizational principles that are brought forth by the perceiver, him or herself. Okay. So let's put that in there. And I am going to be very careful here about what I mean by innate. Okay, so the idea, I guess we'll say, is it's not, these laws of organization are not something that need to be learned. They seem to be something that a child is able to do right away. But if you want, I'm going to try to fine-tune what I mean by this in just a second. I don't think the Gestaltists would want us to think, oh, the child is born the child is born with the knowledge of how to organize the elements. I don't think they would want to say that, but we'll just put it in there for now. Anyway, when the sensations, whatever those sensations are provided, these innate laws of organization are applied, and that's what gives rise to the perceptual experience. Okay. And so the goal of the Gestalt psychologist is to discover the laws and where those laws come from. Where, how are the laws applied? What allows these laws to be applied? And as we're going to see, it's possibly going to be coming from the brain. Okay? That there's some processes of the brain that are going to apply organizational principles to the input, to the sensation. Okay. Now, if you wanted to do one of these for structuralism, by the way, I guess in this little box here, what you would do is maybe put that equation, or put extraction of sensory elements and association or something like that. You could imagine what would go in there. And when these come together, your perceptual experience is completely a function of the sensory elements and the association. That's not cool for Gestalt. Gestalt's saying, listen, we've already shown all these examples that something else needs to be part of this, because you are getting much more out of a perceptual experience than just what can be given by these sensory elements and their association. Whether it's twinkle, twinkle, little star in multiple keys, whether it's apparent motion, whether it's all those little cute examples I gave you on the previous slide, where the elements can be interchanged and you still perceive the silhouette of a cat. Okay, just so you understand the distinction here. So if if it helps you, you can make one of these for structuralism. I probably should have done that, but that's okay. You get the idea. Okay, now the next slide should be just a reminder for you. You've probably been through this in your intro psych class or perception class or whatever. But yeah, it's kind of a nice little reminder. And we'll see things about these laws that will, kind of have implications for the bigger picture. But you remember this, the laws of organization. Just very quickly, let's look at this figure first. And the question is, if I asked you to describe this, what you would most likely say is, I see 3 pairs of vertical lines and then one that's single. One that's that is lonely all by itself, where these are coupled. Okay? But it wouldn't have to be described like that. You could say, well, I see this is a pipe here, and here's another pipe, and here's another pipe, a segment of a pipe. And then this is the one that's by itself. This one on the left is by itself. I think most of us would be less likely to kind of see it that way and also describe it that way, right? Why is that the case? Why do we see these as being a pair and these as being a pair and these, and this is the one that's by himself? It's because, the Gestaltists would say, that one of the laws of organization that the perceiver adds to the input is such that things that are close together are grouped together. Things that are proximate to each other are grouped together. And that's what the law of proximity says. The law of proximity just says that things, pieces of an image, elements of an image that are together are grouped together. That they're together in space, they are grouped together. And that's one of the organizational principles. Cool. Okay. The idea here is now let's see if we can define other organizational principles so we can explain many of the phenomena that I showed on the previous page with the images of the elk and the cat. Here's another one. If I ask you to describe these 2 images, you say, oh, what I see here in the left, and you'll have to help me because I'm colorblind, is I see a yellow cross kind of embedded over blue squares. Is that blue? Yellow and blue? Okay, thank God. Could have easily have been green and purple. But it doesn't need to be seen like that, right? You could say, in fact, what I see is first, I see a rectangle down here, and yeah, it's made of blue and yellow, but I see a rectangle, and I see another rectangle up here that's, you know, made of blue and yellow, but that's what I'm seeing. Then I see a whole bunch of yellow in the middle, but I see this group together, this rectangle group together up here, and this group together down here, but it would be less likely, right? It'd be more likely. And so why are you likely to see it as a crossover squares? And the reason is because, you know, whatever is imposing these organizational principles to the image, they are grouping elements that are similar in their structure, okay, together, in their color together. So we group things that are yellow together, and we group things that are blue together. And the similarity in the physical nature of these things is something that is grouping the image elements. And that's the law of similarity. That things that are similar in their, you know, their physical, you know, appearance are grouped together. Okay. Another one, closure. Sure, these are probably very familiar to you guys. I'm going through this fast because I assume you've been through this stuff before. You can look at any intro psychology text and it's right there. Closure, okay. So let's step back for a second. And if I ask you, what do you see here in these images? You say, okay, well, on the left here, I see a triangle with a notch knocked out. And here I see a square with a bunch of notches knocked out. And here I see a kitty cat with notches, with things taken out, right? Say, cool. So you're saying that this is a triangle, yeah, notches. This is a square with notches, and this is a kitty cat silhouette with lots of pieces missing. You could, however, say, not that this is a triangle, but this is actually, I don't know, two brackets facing each other. So you could have said, this is a lower bracket right here, and this is an upper bracket right here, and they're facing each other. You could say here that this is a little, you know, intersection of two lines that are about the same size, and here's another intersection of one long horizontal and one short vertical. And here you could group these in any way, but you don't. You group them in such a way, so this does look like a triangle, square, and cat, as if the grouping is trying to close the shapes. So they're the most regular shapes that we can see. It tries to close this. And, you know, this is something undergraduates have a problem with. I'm sure you guys can figure this out. You know, clearly this is not closed in the sense that you can perceive the notch, but, you know, on one level of experience, the fact that we're perceiving this as a triangle with something knocked out means that, yeah, the organization is in fact organizing it as if this is closed, so we do perceive a triangle. We know deep down it's not completely closed, but on some level it's closing it, so we perceive this is a triangle, this is a square, and this is a kitty cat, right? So when we, you know, get an image, when we get a group of sensory elements, whatever the heck they are, it doesn't matter too much, the laws of organization will work on the image as if to close them up to make them the most regular shapes. Okay, that's the law of closure. Finally, just one more, and I should say there's a bunch of these. There's 140 something, 144, I think they defined. But the last one is one that's often discussed in the books, so it's worth putting in here. If I ask you to describe this image, how are you perceiving this image down here? You'd say, oh, it looks like there's a smooth wave that's superimposed on a square wave. You know, I see this is one wave here, the smooth wave, and I see this kind of straight square looking wave as something separate, okay? However, they don't need to be grouped like that. Oh, shoot, this kind of looks messy on mine. Okay, this is the way I think most of it's group it, but they could also be grouped like this. That is not the common grouping. And the reason is, the Gestaltists would say, this law of good continuation. In other words, there is an organizational principle that takes the image elements and groups them so we like to see continuous lines, continuous forms. Okay? And that's just how the organization works. And it's just like proximity, similarity, and closure, is that it's imposed on these elements. It's, again, regardless, to some degree, regardless of what the elements are, good continuation is going to be one of these things that's going to determine our perceptual experience. Okay. So, as I said, there's 144 of these. I don't know, maybe you folks remember others from your classes. I can't remember that many. Most of them were done for visual stimuli. Some were done for sound. Let me say something, just interject this here. Gestalt psychology, is Gestalt psychology something that we reference very frequently in modern research? And I would say there are folks that still consider themselves Gestaltists in some ways when it comes to visual perception, not that many. However, if you like Gestalt psychology and you're really interested in how it's being applied in a modern context, music perception. Music perception is the most Gestalt of all the fields right now. So if you're interested in music, and you can see how these would work, determining where a melody is going to resolve, twinkle, twinkle, little star, how I wonder what you are. So it's resolving to that last note. The music perception psychologists will say that's based on the Gestalt principle of good continuation. The way you're able to hear a different melody in the violin section from the trumpet section is based on the law of similarity. You hear the notes coming from the violin sounding similar in physical structure, and the notes coming from the trumpet section sounding similar in structure. So they're being grouped as separate things, right? So it's really big in perception of music. Okay. Anyway, let's get back to what the Gestalts were saying back in the early 1900s. And what they said is, in all of these cases, these 4 cases I have laid out here, and the 144 cases that they came up with of grouping principles, there's something overarching. There is a kind of big ideal that kind of dictates into how these things are working in general. And it has to do with simplicity. And they called it a law of Prognons. And I don't know German, but I don't know if that means practicality Prognons. I can't remember how that translates. But really what they're talking about here is that all the laws of organization work on the notion that we're going to see the simplest configuration of the image elements. We're going to see the simplest configuration, which means proximity, similarity, closure, good continuation, etc., are always going to move towards, I guess, the most simple, the most, I don't know, I guess, stable sort of image. Now that sounds a little kind of ambiguous, doesn't it? What does it mean? What does simplicity mean? I know some of you guys are thinking it's like, that's a very intuitive way of thinking of it, right? Yes, I see these as squares and rectangles because that's simple. But, how do you define simplicity? Is there, you can make it intuitive, and you can make it, we have a gut feeling for what simplicity is, but boy, you want to do this in a scientifically rigorous way. What does simplicity mean? And I should say, to be fair to, Wertheimer and all those folks, they did have actually mathematical ways of trying to identify simplicity in images. They were more careful than that. However, sometimes when it's referred to, it's not really, it's not being very fair to them, I think, just to say this is how they explain things. The reason we perceive things in their simplest configuration is because that's how the brain wants to work in its simplest form. Okay, that sort of circular tautological sort of explanation is something scientists know they shouldn't use. Okay, it's very often used as a straw man example, though. Okay, but the idea here is that we can just use this, that when it comes down to it, the perceiver wants to organize the elements in their simplest configuration. That's what law of Prognons means here. Okay, let's move on here and talk a little bit about kind of some of the more, I guess, more theoretical considerations when it comes to the Gestalt approach. And this is kind of something that's, look at that picture of me. My God, I had hair. That's an old picture. think that was the first picture ever. This is obviously an old slide. It's classic stuff. But this is one of the first pictures taken to me when I got on campus in 1989. Okay. Anyway, this guy you're looking at is Franz Kohler, I think it is. Kohler is his last name. And he asked this great, stupid question. Why do things look like they do? In other words, he wants this to be able to apply to the Gestalt principles. Why do things look like they do, right? And another way of, you could make it more sophisticated. You could make it more cluttered by making assumptions about the Gestalt approach, saying, why do we organize things the way we do? Okay? But we're not going to do that. Kohler appreciated the stupid just like I do and wants to do this from first principles. Why do things look like they do without making any assumptions about Gestalt or structuralism or anything like that? Instead, he said, let's just look at what's available to the perceiver. What's available to the perceiver is a distal stimulus, right? So we know we perceive things in an organized way. In organization, he's not even defining by his laws of organization. He's just saying, we perceive the world as an organized thing. Does the distal stimulus have organization? Is there something out in the world that has an organization? Okay, that could be one possibility. Another possibility could be maybe the proximal stimulus has this organization, right? Maybe the organization that we are experiencing the world with is given to us at the proximal stimulus, at the level of the retina, at the level of the cochlea, at the level of the skin. Okay? That's another possibility. But if you're going to reject those two possibilities, and you might have a hint that we have evidence already to reject that, right? Then the only other way that we're able to perceive the world in an organized fashion must be from the brain. That the brain states, one way or another, must have organization. Okay, so our experience of an organized world, whether it's the organized world of the beautiful stream and trees that I'm standing at today, or the organized world of just, perceiving that little elk there as an elk and not just a random kind of collection of blobs, where is it coming from? And so Kohler does a quick evaluation of this. Does the distal stimulus have an organization? Well, in fact, regarding one, no, we have evidence right here that this is really, when it comes down to it, just a collection of blobs. There's nothing in here, right? That is in it of itself organized. I mean, just think about meaning, think about size, all those things. Whatever it has, it doesn't have enough organization to give it to us out in the world. Well, then maybe what's coming to the eye is organized, but we've seen this before too. What's coming to the eye is a mess, right? There's nothing about, even if we talk about like a law of similarity, there's nothing, yes, there are commonalities, there are similarities physically, but that doesn't mean we have to group it that way, right? There's nothing in there about necessarily grouping it that way. That grouping principle of organization, the proximity grouping principle, can't come from this. Again, we're just talking about, little points here that are being stimulated. There's nothing inherent in the proximal stimulus either. The retinal image is really just a mosaic of points that, has no inherent organization itself. Okay, for the organization to be applied to the image, it can't come from the distal stimulus. It can't come from the proximal stimulus, and therefore it has to come from the brain. And what we will do next class is understand how they saw the brain actually applying principles of organization to the input. So we're actually going to go into neuroscience for our first time of the course. Okay? I probably should end here, but save your questions for next time. I have a meeting. Sorry, I went a tiny bit late. Save your questions for next time. Happy to talk about this again, and we'll see you next week. Bye-bye.
See ya.